So for medium carbon and high carbon and tool steels, we must heat treat the tool to get the correct hardness and temper. Each steel has a data sheet that you can find to get the exact temperature for every stage of heat treatment. We're going to look at a basic approach to get good results, but if you want to get perfection, a heat treat oven would be a big help. The first stage of heat treating is normalizing the steel. We normalize the steel to remove any stress after forging. This is done by bringing the metal up to a red heat, as in non-magnetic, and then allow it to cool in there to the side of the fire. When the steel gets to non-magnetic, it changes to austenite. So that's the term that's used for the change in the steel when it gets to the non-magnetic state. Annealing. We anneal the steel to soften the metal for filing, cutting and drilling. We also anneal it to prepare for the hardening and tempering. To anneal the steel, we heat it again to non-magnetic, put it into a bucket of vermiculite and leave overnight to cool slowly. Another option is to leave it in the ashes of the fire as the fire is dying down after finishing at the forge, and let it cool very slowly in the ashes overnight. So to harden the steel, we heat the annealed or normalized steel again to non-magnetic and quench in water. So this is a fast cooling. Or if it's a high carbon steel, we'd quench in oil. And this gives us martensite. This hardens the internal structure and it's like glass now. It's very hard and easy to break, kind of brittle. So we need to temper it immediately to prevent cracks and internal stresses. Tempering. This removes some of the hardness after hardening. We heat the bar slightly to see straw, then purple and blue colours all travelling up along the bar to the tip. So for our tools, when it's tempered to a blue colour, we'll quench it, and that'll lock in the hardness and toughness to get the best tool. We'll repeat it a second time then to remove any remaining martensite that may be there. To summarise that process again, in a chart, let's say, if this is the temperature line and this is time here, we bring up the temperature piece to non-magnetic, that's called the austenite. We quench quickly in the water and we get back down here to martensite. Then we bring it back up a certain amount into those straw, purple, blue colours. The different colours would give a different temper, and that tempers it. Quench. Traps that in. And then we temper a second time. Quench. So that's your hardening and tempering. So here's our round punch, and we're going to begin by normalizing it. So we heat the tip until we get it non-magnetic. So there it is. You can see the way the main part is magnetic, the tip isn't. So we just leave that on the side of the fire to air cool. So here we are showing how to anneal it then. So after the normalizing is done and it's cooled, we anneal it, get the whole bar non-magnetic and push it then into the vermiculite. Leave overnight. So following that, I have a bunch of these tools now that we've made, and I'm going to harden and temper them. So I'm heating them up, the tip of each one. The drift I'd heat up a longer section because the center part, the main body of the drift will need to be no harm to harden and temper that. So the tool that I have here, I'm heating up the tip and getting it to non-magnetic. So we're going to harden this tip as soon as it's non-magnetic. So we have it non-magnetic now, and we're going to dip the tip about half the bar up and down in the water. Stay there. Don't think you've done when the colour is gone. You have to remain there. So you can see the way as it comes out, the water isn't evaporating then after a while. And that's when you know the tip has cooled down enough. Now, if you can sense all that very accurately, you could actually use the remaining heat that's in the middle of the bar to temper the hardness out of it. So now I've grinded the steel to make it shine, and we're going to reheat it now to temper it. We want to get rid of some of that hardness. The tip of that tool now could chip, could break, and especially for instance if you're hardening a knife blade that's thin, it will become very brittle. So the practice is you temper it after hardening, you don't leave it. So what I want to do now is heat the center the main body of the tool. And I'm heating that center main body. And the shiny part that I grinded then, you can see the colour starting to travel up along. So there's that purple, so the straw is up a bit higher than the purple colour there. So you leave the bar on top of the fire with the fire set low. Don't have a high heat fire. So once again, there it is, travelling up along, nearly there. So there we are. So that's the tempering. We let the colour travel up along, and the tempering took some of that hardness out of steel from the hardening. So I'm going to do a second temper. So the main shaft and the hammer end of the tool, they heat up, cool down a bit slowly, but we're not hardening them. So the most that would happen, the main shaft, is that it would become normalized, which is okay. The tip, nothing much happening yet, so we're going to heat that main shaft, the main body more, and then from the main body the heat has to travel up to the tip. We're not heating the tip directly in the fire here. So they're starting to happen. The tongs is holding the hammer end of the tool. So the hammer end was annealed and it stays annealed. So that's the softest state. So here's the colour now travelling up along the tip, and to do another little heat to get it to move up along. So there it is now, the second temper being on. So the tongs is holding the hammer end of the tool, which was annealed. We didn't affect that. Heating it a bit doesn't affect anything, which is only if you get it up into the austenite, which is the non-magnetic, the high red, low orange kind of colour. So again, I want to make sure to keep that there a while so that it doesn't lose its temper with the heat. If the main body of the tool still had a lot of heat, it could travel up along the tool and do more than just tempering. Could lose its temper then and soften it. So I've all the tools done there now. This is the round punch at the end. You've got a second temper. And that's the tools. Normalised, annealed, hardened and tempered.